Hello, and we are on to the next video. We are now proving lines are parallel. So in the previous ones, what we were talking about were angle pair relationships based upon the fact that we knew that two lines were parallel and then cut by that transversal, and we came up with all those angle pair relationships. So now today we are going to look at all their converses, and now we're going to actually show or prove that those lines are parallel based upon information about the angles. Okay, so this is different. Before we already knew they were parallel. Now we don't know that they are parallel. Okay, so let's take a look at all the converses. What you're going to say, remember, converses are the flip of those original conditional statements. So the first one said, if the lines are cut by a transversal and they were parallel, then this happened. Well, now we're going to go the opposite way. Okay, so for example, the corresponding angles converse says if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel, versus the original one, which says if two lines are cut by a transversal and they are parallel, their corresponding angles are congruent. So continuing that, we have our alternate interior angles converse. Same idea, same side interior angles converse, and all three of those state that they are congruent, the lines are parallel. And then our alternate exterior angles converse. At this time, it would probably be a good idea for you to hit the pause button and write those down. All right, so let's actually use them. So for our first example, we want to find the value of x that makes m parallel to n. And what you're going to find is that these problems are very similar to the ones that we found in our last lesson that we talked about, because we're going to solve them the same way. What we want these two things to be, since they are what kind of angles? Well, if this is in the same spot, they are corresponding, so we want them to be equal. So I'm going to take 3x plus 5 and set that equal to 65 and solve for x. So let's go back to those lovely days of algebra. Subtract 5 divided by 3, we get the value of x is equal to 20. Okay, so what that means is if I were to put 20 back into there, that means those two corresponding angles were congruent, and then the corresponding angles converse says that the lines are going to be parallel. Okay, moving on, is there enough information to conclude that the measure or that m is parallel to n? So here we're not actually solving for anything. What we really want to know are the two lines there going to be parallel? And so right now I don't have any kind of special angle pairs on there. We don't have any same side exterior relationships that we want to talk about, so we need to find one. You can find the angles that are supplementary with the angles that are given here, and if I were to do that, what do I find? Well, these, since they are next to each other, they're adjacent, they form that straight angle, they are, in other words, a linear pair, they're going to add up to 180, they're supplementary. Okay, so we know that that's 75. And now from here we can use that corresponding angles converse, and that allows us to tell us that m is parallel to n. Okay, so this is an example of not necessarily solving for x, but solving for some pieces to show that lines were parallel. All right, so moving on here, we want to figure out, can we prove that A is parallel to B, and then why or why not? So looking at this diagram here, I have A and B right here, and here's our transversal. I want to know, are they parallel? So taking a look at the markings on here, even though there's no numbers, remember that those arches imply that the angles are congruent. So yes, those are alternate interior angles converse. Those are alternate interior angles, and if they're congruent by the converse, it means that they're parallel, so there's enough information. So now I want to take a look at this guy right here. I'm saying the measure of angle 1 plus the measure of angle 2 is equal to 180. I really want you to give yourself a moment to think about that. Does that imply that A and B, these two lines here and here, cut by that transversal, does that mean that they are parallel? Well, if they were 90 degrees each, then the answer to that would be yes. But we don't know that they're 90 degrees because we don't have any of that box in there that says, yes, these are right angles, or any kind of degree measure. The only way that this can happen is that these two here were equal, and that's if it's 90. So it's not enough to say that they add up to 180. So supplementary angles does not mean they have to be congruent. Okay, so that's what we're looking for. Our last one, oh, proofs. Who doesn't love proofs? Yay! All right, in this figure, R is parallel to S. So I already know that this line here is parallel to this line here. So both P and Q are going to be transversals. And I know that angle 1 is congruent to angle 3. So this angle here, angle 1 is congruent to angle 3. I'm trying to prove that these two lines here next to each other are going to be parallel. So really, if you look at it, to show that these two guys are parallel, I need to show a relationship between angle 1 and 2. So let us start out with the given. So our given here says that R is going to be parallel to S, and we can say from that, R is parallel to S, we can say from there is that, I pointed out the wrong one. Angles 1 and 2 go with R and S. We're trying to show a relationship between angles 2 and 3. My bad. Sorry about that. Okay, moving on. Since the R and S are parallel, so here is parallel, this Q is a transversal. I know that angles 1 and 2 are congruent. And what tells us that? That is our corresponding angles postulate. They're in the same position. If they're parallel, they are congruent. So I know that angles 1 and angles 2 are congruent. So now the other thing is, from our given, angles 1 and angles 3 are congruent. So I know that angle 1 and angle 3 are congruent. What I can essentially do here, since angle 1 is congruent to angle 2, angle 1 is congruent to angle 3, I now can say that 2 is congruent to 3. And that's transitive property. Remember, we cut out the middleman, even though it's a little bit backwards there. So 2 congruent to 1, 1 congruent to 3, we're going to cut them out and go right to each of those right there. Well, if 2 is congruent to angle 3, what kind of angles are these? Well, if you remember, two parallel lines, well, they're not necessarily parallel, but potentially parallel lines. Here's our transversal. These guys here are called alternate interior. So because they are congruent, P has to be parallel to Q, and that is our alternate interior angles converse. It does make a difference if you're using the converse or the theorem. So please make sure you are using the appropriate terminology. So overall, what is the big difference between using the corresponding angles converse versus the corresponding angles postulate? There is a difference, okay? Make sure you have this good understanding. Converses proves lines are parallel. The postulate proves that angles are congruent. Now this is different, say, for like the same side interior. The converse still proves the lines are parallel, but the actual theorem says that they are supplementary. So just keep that in mind. So that is the big idea and big difference that I want you to get out of this lesson. If you have any questions, make sure you are asking those. Otherwise, go on to your practice.